Okay, this is Algebra 1, Section 3.1, Graphing Linear Functions, page 143. I'm going to start with kind of a weird thing. I'm going to take a look at this right here. Let's say that we have 4x minus 3y equals 8, okay? And this is from the last chapter, but we're going to use it a lot in this chapter. I want to show you some things that we can do to help us quickly. This is kind of a shortcut, so if you like shortcuts, this is what you need to know. Now, you should have your notes out, and you should be taking notes alongside of with what we're doing. We're not just going to be graphing, we're going to be taking notes. So, all right, I see that most of you have not got your notes out. So, okay, at the end of the chapter, we learned to solve for a variable, didn't we? Okay, and if there's more than one variable. So the first thing I'm going to do is I'm going to change this to plus and negative, and I'm going to have you solve for y. Okay, now there's a reason I'm having you solve for y, because you're going to learn to solve for y a lot. But what I want to do is I want to show you a shortcut. I want to show you how to move things around, okay? All right, because you're going to be doing this a lot. Now, in order to solve for y, what do we have to get rid of first? All right, and we'd subtract 4x from both sides. I want to show you a shortcut. You ready? What happens when I move the 4x to the other side? Have you been paying attention?
You have to put it off to the side.
Yes, and what happens to it? Does it just become 4x on the other side? What does it become?
Negative.
It becomes negative. If you move something, listen very carefully, if you move something to the other side of the equation, it becomes the opposite of what it was on the other side. All right, so here's the little trick, Jackson. When I move this over, I don't have to subtract anymore, Jackson. I can just go a negative 4x plus 8. Whoa, what happened? I moved it to the other side, Jackson. It became the opposite side of what it was. We've done this long enough, I'm hoping that you can understand why this happens. And look, I didn't have to subtract it. That was kind of nice, wasn't it? All right, now what do I need to do?
You need to get rid of negative 3.
I need to get rid of negative 3. Now there is no shortcut for this. I have to divide everything by a negative 3, right? So I divide this by negative 3, I divide this by negative 3, and I divide this by negative 3. I want you to do it separate now. Okay, so you get y equals, what's a negative divided by a negative?
Positive.
A positive. So y equals 4/3 plus a negative 8/3. Notice how I forgot the x. And notice how I separated this, okay? All right? All right, folks. There's a reason I showed you all this. I want you to move things around, okay? Let's go back and let's take this plus a negative 3y equals 8. And now let's solve for x. Okay? So what do I have to move over? The negative 3y. And what happens when I move it over? It becomes positive. And I'm going to put it first. Do you see that? I don't have to subtract anymore, Jackson. Are you okay with that?
Yeah.
It works for numbers, it works for variables. And now what do I do, Chuck? I get rid of 4. And how do I get rid of the 4? I divide it by what?
4.
And I divide both of them by 4. So I get x equals 3/4 y plus 2. Where did the 2 come from?
You simplified.
Okay. All right. So are you okay with if we move things to the other side, it just becomes a different sign? Caden, are you okay with that? I knew you would be. It's kind of nice, isn't it? We don't have to show all that work. Braxton, we good?
Yep.
All right. Good. Okay, so what's this got to do with what we're talking about? Well, I'm going to show you. Okay, we're going to talk about linear equations. All right? Linear equations. And I'm just going to get this out. Linear equations come in 3 forms. Can be written in 3 forms. All right? Stay with me, Braxton. Okay? Can be written in 3 forms. The first one is standard form. And that's what we're going to talk about today. the second one, leave some room because we're going to talk a little bit about each one, is slope-intercept form. And the third one is point-slope form. This is the one I'm going to deal with today, the big star. Okay? We good? All right. Standard form looks like this. Oh, by the way, every line can be written in these three forms except for two types of lines, and I'll talk about those two types today. But this one is AX plus BY equals C. What do you notice about the A, B, and C, Tirsa? Yes, Miss Denny. They're capitalized. If I ask for the general standard form, you write AX plus BY equals C. Okay? Tyra, you understand that? All right. If I ask for the slope-intercept form, you put Y equals MX plus B. Now you will notice, if you look above Chuck on the wall, clear to the top, there it is in purple. So this is called slope-intercept form. It is very important. Okay? And the last one, point slope, is the hardest one to memorize. You might want to start now. It's point slope. And let me talk to you. It says y minus y sub 1 equals m times quantity x minus x sub 1. Now we're going to tell you what these letters mean in a little bit. Jackson, it's not up on the board. So we're going to tell you what these letters mean in a little bit. All right? Not when I say a little bit, not today. These two are for another day. Okay? I will tell you that slope-intercept form, this is what I call the graphing form. Okay, this is called the graphing form. And point-slope form is called the blue-collar form. What does blue-collar mean?
Working class.
That's right. He does all the work, gets no credit. He's the offensive line, gets no credit. Which one are we going to focus on today again, Allie? Standard form. Okay? All right? Turn to the person to your left and say slope-intercept form, please. Turn to the person to the right and say point-slope form. Thank you. All right? You're not participating very well. You need to know these forms. Okay? All right, the standard form, it also has a name. I call it the tuxedo form. Why do I call it the tuxedo form? Because it looks nice, but it really doesn't provide any kind of thing for us. But we are going to talk about it today. All right? Now let me talk about A, B, and C. Capital A, capital B, and capital C. Do you notice that I've emphasized capital? Because when I ask for it on a test and you guys write it out, I always have, and it's usually a girl, I don't mean to be sexist, but they write, because they like their fancy writing, they write one of them in lowercase because it just looks neater. Well, it's going to be checked wrong. So you can look neat, but it's going to be checked wrong. If I ask for the general form, it's capital A, X plus capital B, Y equals C. Notice that X and Y are lowercase, right? All right. All right, these guys are integers. What does that mean? Can they be fractions? No. They're whole numbers, but can they be positive or negative?
Yep.
That is correct. They can be positive or negative, but no fractions, no decimals if it's in standard form. It doesn't have to be in standard form, but if I ask for it in standard form, it can be no fractions or decimals. Do you understand that, Mr. Lords? Well, good. You know the reason I'm asking you these questions because I've taught this for a few years, and I understand that students this is where they make their mistakes. Okay? I'm going to make one exception, and this is a Mr. Ellis rule. This is not a rule that's universal. This is Mr. Ellis's rule. A has to be positive. That is a Mr. Ellis rule. Sorry, positive doesn't look so good. Positive looks pretty negative. No, A has to be. This A right here. That A right there has to be positive. Okay? I make A positive. That is for our benefit. Okay? That way we all have the same answer. All right? Okay, so A and B are called, watch this word. Oh man, I gotta erase this line so it's not. A and B are called coefficients. They are numbers. They are called coefficients. I didn't leave myself enough room. Can I erase the slope-intercept and the point slope? So we're not talking about them today. I just wanted to introduce you to them. Okay. I'm also going to tell you that C is called a constant. That means it's just a number. Okay, hanging out by itself. Now A and B are numbers also, but they are in front of the X and the Y. The X and Y are what you graph. You see that little graph thing that you got? That's what you graph. Okay, now these are called all underneath linear equations, right? What do you suppose linear stands for? What do you suppose linear stands for? It's a line. So when we graph these, what are we going to get? A line. Okay? All right. Well, let's not graph them yet. We got to put them in standard form. Remember when I said we're going to move things around? All right. So we want to determine whether equation is linear. It's a yes or no question. And then we want to, if so, if yes, write in standard form. All right, I'll let you write that, and then I'll give you an example. Okay? Now, determining whether it's linear or not does not mean that it has to be in standard form. Okay? All right, y equals 4 minus 3x. Okay? Is this linear? Well, I'm going to tell you the answer to this. I'm going to give you the first one. This is yes. Is it? It's a yes. So is it in standard form? In other words, is it in the form where x and y are on one side and the numbers on the other? No, it's not. But it is linear. And here's why it's linear. It has a y and it has an x. There's no multiplication. This is actually in slope-intercept form, or pretty close to it. It's in a different form. Okay? It means that what you guys do, when you come to school and you're wearing, when you go to gym, you look differently than when you go to prom. Right? This just looks differently. It's in his gym clothes. Okay? And the point slope, I say it's in his gym clothes because that's the working one. This isn't quite tuxedo form. This is how we graph it. Okay? I'm not going to show you that right now. But what we're going to do is we're going to put it in standard form. You ready? Mm-hmm. What I'm going to do is I need to move the 3x over, don't I? So this is plus and negative, right? When I move it over, what does it become? Positive. So I have 3x plus y equals 4. Correct? Now, is it in the correct form? Well, is a an integer? What is a? 3, that's an integer, right? What's b? What? No, b is not y.
1.
But b is 1, lazy Americans. And what's c?
4.
Are all 3 of those integers? Yes. Is a positive?
Yep.
All right, then we're good to go, right? There it is, standard form. All right, number 2. 6x minus xy equals 4. Is this linear, or is this a linear equation? Tirsa says no. Why, Tirsa? All right. This guy right here, this is a no. You cannot multiply x and y together. They have to be separated. So since it's a no, do we have to put it in standard form? We do not have to put it in standard form. Okay? All right, look at this one. Y equals x squared minus 4. Is this a linear equation? Caden? What do you think? No. Why? It has an x squared term, this guy right here, so it's a no. Alright? Now this one's going to blow you away, but I'm a little love. Okay? Let's do this one. 1/3 y equals a -1. Okay. Now I'm just going to give you the answer to this one. This one is a yes. Okay? This one's a yes. And you're going to go, well, it doesn't have an x. And it has a fraction. You can have a fraction as long as the x and y aren't in the denominator. But it doesn't have an x. You don't need an x. Because you see this right up here in standard form? X could be 0. I erased it. In standard form, a could be 0, right? A can be 0. Isn't a an integer? Remember, it goes ax plus by equals c. Isn't a an integer? Isn't 0 an integer? And what's 0 times x? 0. So we don't need to have an x. Can we have it? Can we not have a y? Can we not have a y? Yes. All right. So people, if we do not, listen very carefully, if we do not have an x or a y, we just have one or the other, right? These are the two evil twins. They cause us problems. They are a horizontal line and they are a vertical line. And they are the twin brats. They are a pain in the rear. Okay? How do we deal with them? All right? Well, what we do is we solve for whatever variable's there, which is what? Y. So we're gonna solve for y. That means we're going to multiply both sides by what? 3/1, or 3. So I get y equals a -3. Okay? This, my fast furry friends, is one of your two nemesis. These are the guys that cause problems. This is a horizontal line. He's a horizontal line. Anything in the form x equals some number is a horizontal line. And they don't follow, that doesn't look like it's in standard form, does it? But it is. And let me tell you why. What's a in this case? No, what's a in this case?
0.
0. Thank you. Somebody was listening. What's b? A is 0. B is?
1/3.
No.
1.
1 in this form. C is what? -3. Thank you very much. Are all three of those integers? There you go. All right. So if I have this, if I have 5x equals 30, okay, how do I solve for it? This one's the other evil twin. Because there's no y, is there?
Nope.
So what do I have to do? Divide both of them by 5. And I get x equals 6. This is a vertical line. And this guy is really a pain in the rear. Okay, he's a vertical line. A equals what?
0.
Nope. A equals?
5.
Nope.
1.
1. Thank you. B equals?
0.
0. C equals?
6.
All right, are those all integers? Is there anybody that does not understand where those three numbers came from? You need to understand. Okay, I want you to memorize these two guys. Yep.
Where'd you get A and B from?
Okay.
How'd you get it?
All right. Remember, it has to be in this form, right?
Yeah.
Okay, so it's 1x plus 0y equals 6. 0y is 0, and 1x is x. Does that explain it to you?
Yeah.
All right. Does everybody understand it? You got to understand the evil twins. They are a pain in the rear because we don't recognize them. They hide themselves. One is vertical, one is horizontal. This one's vertical, x equals 6. You want to know how to graph this? Okay? Let me show you how to graph y equals a -3. It looks like this. And this is a -3, right? All right, you want to graph the vertical one at 6, it looks like this. This is at 6. If you count over 6, this is what it looks like here. And if you count down 3, this is what it looks like here. Does everybody understand that? They're vertical and horizontal. Okay. All right, so what I want you to do is, I'm going to erase all this. I want you to tell me, what number am I on?
6.
6. I want you to tell me 2/3 y equals a negative 1, no, let's make it positive, 1/2 x plus 5. Okay. Is this a linear equation? It is. It has an x and y. There's no multiplication of them. There's no squares. It is. But you got fractions, right? And you also have the x on the right side. How do we move the x to the left side? We just bring it over. And once we bring it over, it becomes... Thank you. All right? Now, are these three fractions, or are these all integers? Is a negative 1/2 an integer? Nope. Is 2/3 an integer? Nope. So what do? Well, we multiply the whole thing by the least common denominator. What's the least common denominator between 2 and 3? 6. So I take 6 times a negative 1/2 x. I take 6 times 2/3 y. And I take 6 times 5. Don't forget the 6 times 5. And this cancels with this. And I get a negative what? 3x. Plus this cancels with this. And this is a 2. And 2 times 2 is 4y equals 30. Jackson, do you see where I got a negative 3x plus 4y equals 30?
Yes.
Do you, Allie?
How did you get the 4y?
The 3 and the 6 canceled, and I got 2 and 2. 2 times 2 is 4, right?
Yeah.
Okay. Now, is negative 3, 4, and 30 all integers? They are. What's the only problem? Stay with me.
They have variables.
Nope. That's not a problem. See this guy right here? I said A must be positive. So we're going to divide this by -1, divide this by -1, and divide this by -1. We divide by -1, we get 3x plus a negative 4y equals a negative 30. Basically, all it does is turn everything to the opposite sign, correct? Right? All right. Remind me tomorrow we need to go over your tests. I haven't gone over your tests, have I? Have I gone over your tests? No, we'll do that tomorrow. Okay. Now we're going to graph. Now, this is where that graph board, you wonder what we were going to do with that, right? How many points are on a line? That's what determines it. That's all I need to graph a line. How many points are on a line? Infinite. Infinite. Okay? We only need 2, as Ryan says. We only need 2. Okay? So this is a line, guys. Anything in the form ax plus by equals c is a line. All right? Let me show you how to graph it. We're going to graph 2 things. We're going to make points. So this is called a t-table. You need to know that. It's called a t-table. And what we do is we put values in and we get values back. And so what we do is we create ordered pairs. Ordered pairs, right? Okay. So I'm going to create some ordered pairs. You want to know what the easiest ordered pair to create in the world is? 0. All right, 0. If I put 0 in for x, all right, so I put 0 in, so I put it in the t-table. I'm going to put it right there. So what happens is I have 3 times 0 plus a negative 4y equals a negative 30. I'm going to run into my t-table. Does everybody see that? I actually put 0 into the equation. Tirsa, do you see that? Ashley? Okay, what is 3 times 0?
0.
So I get a negative 4y equals a negative 30, right? And I divide both sides by negative 4, and I get what? Y equals a negative 30 divided by 4. Negative 4 is a positive. It goes in there, what, 7? It's 28. 7 and 2/4. So 7.5, right? Right? So when I put 0 in, what do I get? 7.5. This is an ordered pair. Okay? This, my fast furry friends, is called the y-intercept. Do you know what it means to intercept something? You touch it. So why is it the y-intercept? It goes on the y-axis. So it's called a y-intercept. That's pretty amazing, isn't it, Jackson? Okay, Jackson, if there's a y-intercept, do you think there's an x-intercept?
Yeah.
All right, let's look for it. And what would I do to get the x-intercept? Well, let's see. How did I get the
You
y-intercept?
would switch the two around.
What do you mean I switched the two around?
Put zero. Switch.
I put 0 in for what, Ashley?
Put 0 in for y.
Y. I put 0 in for y, that gives you the x-intercept. So I'm going to put 0 in for y, okay? All right, notice see, this is the y column, so I'm put 0 in for y. So then I have 3x plus a negative 4 times 0 equals a negative 30. Notice I put it in for the y, right? So now I have 3x equals a negative 30, right? And if I divide by 3, what do I get? X equals, how about a negative 10? So we have the ordered pair, a negative 10, 0, right? And this is called the x-intercept. How many points do I have, Ryan? 2. How many points determine a line? 2 determine it, but I have infinite on it. All right, so let's go to our board. Right? All right, let's graph these 2 points. You ready? Now you're going to need a straight edge. Okay? A ruler of some sort, protractor, whatever. I'm going to go up 7.5. 1, 2, 3, 4, 5, 6, 7.5, and I put a point. This is called the y-intercept. This is called the y-intercept. You see it? It's right up here. Now, I have a negative 10 as my x-intercept, right? So I go back how many? 10. That's the x-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here, right? What do I do at these 2 points? I take a straight edge. A straight edge. You don't freehand it. I take a straight edge and I connect the points. Okay? And my fast furry friends, this is this represents this line right here. Put this line over here. I don't know if you can see both. Whoops. Oh, what's at the end of these? I forgot. What's at the end of these? Arrows. It goes on forever. See this line right here? That's what it looks like physically. See this line right here? That's what it looks like physically. Okay? All right. You understand it? Okay. Good. Let's do another one. Would you go? Do you have straight edges? You don't have straight edges. Nobody has a straight edge. Okay. Back there in that white container, Tyra, would you go back in that white container underneath the one that you grabbed with the markers? I think you were doing the markers. Would you hand everybody a I want these back. Actually, yeah. Yeah. Okay.
The paper ones?
That's fine. Whatever. They still make a straight edge. Okay. All right, what I want you to do is, while she's finishing that, I'm going to give you another one. Okay? But I'm going to put it in a different form. Okay, I'm going to put it in a different form. Now this is not in standard form. It's linear, but it's not in standard form. Pay attention. It's linear, but it's not in standard form. So I'm going to do a t-table. Okay, this time I'm going to mess with you a little bit. I'm going to do more than 2 points, just to show you that you can do any points. Okay, I'm going to put in for x, and I usually put in for x, but you can put in for y. I'm going to put in for x a -1. Okay, a -1. Everybody got that? We good? So I'm going to take 6 minus 2, and I'm going to actually put it in, whoops, that's for x. This is 2y equals a -3 times a -1, right? We good? So I have 6 minus, or plus a -2y, right? I changed it to plus negative, equals +3. Now I'm solving for y, right? I'm going to solve for y to find out what my y value is. So I'm going to move the 6 over. So I'm going to subtract 6 from both sides. This is normal, right? We've done this before, right? So I have a -2y equals a -3, and then I divide by -2. And I get y equals 1.5. Is that correct? So instead of doing my points here, I'm going to show you that this point right here is a -1, 1 1/2. Right? Is that an x or y intercept? Is it an x or y intercept? No. No. Okay, so now I'm going to put in something for y just for fun. You can put them all in for x, you can put them all in for y, or you can change them off. I'm going to put in, let's put in 1 for y. Notice I put it in the y column, and I do the work over in the x column. So I go 6 minus 2 times 1 equals a -3x. Does everybody understand what I just did? Braxton, do you have a question?
No, I'm just stretching.
Okay. Is this an x or y intercept? No, it is not. I just chose a different point. So now I have 6 minus 2 equals a -3x. 6 minus 2 is 4. So I have a -3x, and I divide by -3. And I get x equals a -1 1/3. Do we see that? All right? And so I have the ordered pair. I'm going to put it over here. I have a -1 1/3. Make sure we write it correctly. Notice I put the -1 1/3 first because it's x, right? All right. How many points do we need? 2. But can I show you something? I'm going to make 3 just for fun. And I'm going to go ahead and put 0 in. So this is going to be what? What's this name called? If I put 0 in for y, what's it called? What's it called if I put 0 in for y?
Y-intercept.
It's called an x-intercept when I put 0 in for y. When I put 0 in for x, it's called a y-intercept. We got that? So I put it in there. 6 minus 2 times 0 equals a -3x. This is 0, correct? All right, so I have 6 equals a -3x. So I divide by -3. What do I get? X equals what? -2. So I'm going to put this point over here, a -2, 0. This is called the x-intercept. All right, how many points do I have? 3. Are you ready? Let's go graph it. All right. I'll graph the first one. Oh, do you remember what they were? I'll put them up here so you remember. You probably have them in your notes, right? The first point was a -1 1/2, right? So I go a -1 and then 1 1/2. I'm sorry, it's 1 1/2 right there. Everybody see that? I'm going to put the next one in. A -1 1/3. So it'll be right here, and then 1, right? So it'll be right here, right? And then a -2 0. Oh, what do you notice about those 3 points?
They're close.
They're close, yeah, but what else do you notice? They're in a line. They better be in a line, right? What would happen if I found 3 more points? They would be on the same line, and if they're not on the same line, guess what? You made a mistake. These 3 points have to be on the same line. So I take my handy dandy straight edge and I write it like this. Here's my x-intercept, here's my y-intercept. You understand this? But notice, any lines that I graph have to be on the same lines. I still have arrows, and this is a representation of, guys, this is a representation physically of this line. Okay? This is like it's signed, right? Okay. So here's your assignment, and you're not going to be able to do it all, but I want you to do it. Try to do half of it tonight, right? It's page 147, and I'm going to have Ashley write it on the board. Numbers 13 through 39. This is the basis for the whole chapter, so we want to get it down fairly quickly, okay? So page 13 through 39, you should be able to get through, I'm hoping, like around 27, 28. It'll be a little hairy. I mean, you'll have to go back. You may have to look at the video a little bit.